let's try to understand this question. So synthesis of aspirin. So this can be made by two reactions. So the reaction number one is given to you. Salicylic acid, acetic anhydride will give you aspirin and acetic acid. The details are here. The molar mass is there. Yep. Reaction number two, again you are going to make aspirin from salicylic and acetic anhydride. Okay, hold on. So this is liquid acidic chloride. So this is wrong here. Liquid acidic chloride and salicylic acid will give you aspirin and then hydrogen chloride. Right. So all the details are here. So results. For reaction A1, the percentage yield is 85% and the percentage atom economy is 75%. Okay. For every 2.1 gram of salicylic acid reacted in reaction A2, 1.8 aspirin is produced. So 1.8 gram is produced. So every 2.1 gram of salicylic. So 2.1 gram of salicylic is reacted. Okay. Calculate the percentage yield and percentage atom economy of reaction A2 and compare them to the result of A1. So the A1 percentage yield is already here. So percentage yield is here. Atom economy is here. So you need to find the atom economy and the percentage yield for the reaction number 2. Yep. Yeah. So yield means actual yield divided by theoretical yield, right? Yeah. Multiply by 100. What is atom economy means, Vihanga?
Molar mass of the product you are looking for divided by
Huh?
the molar mass of the reactant.
Say it again.
The molar mass of the substance you are looking for divided by the molar mass of the reactants.
So you can say molecular weight of the desired product.
Yeah.
Right, so it's called molecular weight of the desired product divided by what? Divided by total molecular weight of the reactants. Total molecular weight of the reactants. Weight of the reactants. Multiply by 100. Right, so that's the atom economy here. So, yeah, I will go into the next page. So, how do you find the percentage yield? Okay, so if you read the question, it is given that 2.1 gram of salicylic produces 1 gram of aspirin, right? So the question says 2.1 gram of salicylic produces 1.8 grams of aspirin. So molar mass of salicylic is equal to 138 grams per mole. Molar mass of aspirin is equal to 180 grams per mole. So moles of salicylic, now N of salicylic, I would say sal, is equal to what? 2.1 grams multiplied with, actually divide with 138 grams of per mole. Is that right? So if you do that, what would be the answer? Say it again. 1.52 times 10 to the power minus 2 number of moles, right? Okay, so this is number of salicity. So now tell me, what would be the theoretical yield of aspirin? Theoretical yield of aspirin? That would be this number of moles, because 1-to-1 stoichiometry, right? This number of moles multiplied by the aspirin. How much is aspirin? 180, right? Yeah? 180. How much is that now? 2.74 grams. Right. So now what is the percentage yield now? Percentage yield would be aspirin you get 1.8 grams. Yeah. Divide by theoretical value is 2.74 grams, multiply by 100. How much is that? 65.7. Okay, so there is that. Then let's think about the atom economy. So this is the yield. So atom economy. So atom economy is molar mass of desired product, right? So that means MR of desired product, right? Desired product divide by MR of all. MR of all reactants. Is that right? How much is that now? Yeah. So let's get the values here. So this is going to be 180, yeah? Yeah? 180 is the molar mass, right? Grams of aspirin, right? Divide by how much is the molar mass of the total reactants? You have salicylic and you have acetyl chloride. How much is that? 200? 16.4. 5. Okay, multiply by 100. So then tell me how much is the percentage here? 83.1. Okay, so now if you go to the question, A1, how much is the yield in the question? And how much is the atom economy? Yield is 85, 75. And A2, we have yield is 65.7 and atom economy is 83.1. Okay, so that part is fine, right? So which reaction is better aligned with grain chemistry? Okay, answer is reaction A1. Reaction A1. The reason higher percentage yield. Higher percentage yield, meaning, this is what you need to know, meaning less waste. meaning less waste of starting material. Why? Because we are making more desired product. Less waste starting material. What is the question? And high efficiency. Right. So you can say now we have to talk about A2 as well. Although A2 has better atom economy, right? You can say the significant lower yield makes significant lower yield makes it less environment friendly. Due to material waste. Due to material waste. Okay. So this construction is important. Answer. So in here, so we can say atom economy, I would say E, measures how efficiently atoms from reactants, right, are incorporated into the desired product. That is my starting point. Desired product, right? Rather than waste products. Okay, so I'm going to say what is atom economy here. Then second one, reaction 1, A1, right, has atom economy 75%, means 25% of atoms, 25% atoms, if you look at the equation, end up as acetic acid. As byproduct, right? If you think about R2, so that has atom economy 83.1%, 1% better than A1, I mean better than R1 or A1, right? Doesn't matter. Only 16.9% of atoms form HCl. Making more atom efficient. Okay, this is fine. So we introduce the situation now. Now we have to say atom economy alone doesn't determine the greener process. atom economy by alone does not determine the greenhouse process. Right. So actual yield and practicality, these were the very important words to use. Practicality, right, must also be considered. Okay, so you conclude now. A2 or R2 is more atom economical, right? In theory, A1 or R1 has higher yield, makes it more practical and potentially greener overall. So this potentially greener overall, because that has some atom economy, but yield also very important. So practicality wise, by looking at the numbers, A1 is more greener, right? So